Vectors. So vector is something that has got both direction and magnitude. If you want to represent a vector, true to its nature, that representation should have both magnitude and direction. And there are a lot of vectors. Let us say in our discussion, let's take up force, which is a vector. So whenever I want to talk about vectors in this video, I'll talk about force because force is a vector. What works for a force, it will also work for the class of vectors like force. Okay. So if you want to apply a force, suppose let's take an example like there is a block, you and your friend both are trying to move the block towards east and you're going to apply force, which is a vector. And when you want to represent it geometrically, that geometrical entity should have magnitude as well as direction. Suppose you apply a force F1 and you apply a force F1 and your friend apply a force F2 and you apply 12 Newton force and your friend applies 5 Newton force. Both of you apply force along the eastern direction. Both of you apply a force along the eastern direction. So and you apply 12 Newton force and he applies 5 Newton force. What you do is to represent that you have applied 12 Newton force and you draw a 12 centimeter line or 12-inch line along the eastern direction. Because your friend applies a 5 Newton force, if you had drawn 12 centimeter line to represent your friend's force, you apply 5 centimeter line, whereas the direction is along the same direction. Now the net, and this is called F1 vector and this is F2 vector. Because it has got direction, we mention it with the overhead arrow. Now what is the effect of these two forces? Because the effect of these two forces means they add together. How do you add one vector with the other? Like you just take this vector and add to the original vector. So you will get the total vector. Now the total vector is from the tail of this to the head of that. So this part, the arrow has got a tail and the head. Head is containing that arrow that gives the direction. Now the net effect of these two vectors is this tail to the other vector's head. Now this is what F1 vector and F2 vector. So the net force, let us call F resultant. F resultant vector is the sum of two vectors. Because you have not changed the direction or the magnitude of F2, it is as such F2. This FR is the sum of these two. So FR resultant vector is F1 vector plus F2 vector. That means there are two ways of writing it. How much force you have applied? 12 Newton, and in what direction? East direction. So F1 vector will tell you 12 Newton force along east. F2 vector will tell you 5 Newton force along east. But the modulus of F1 means without arrow it will be represented. It is simply F1. That means without direction we will have to say it is just 12 Newton. And magnitude of F2 means it is just F2 without overhead arrow. And that will give you only the number value of the force. That means the magnitude of the force, but not the direction. This is what the difference between force vector and force. Okay, so now FR is the resultant vector. Resultant vector means you can now, after calculating the resultant vectors, you can remove these two vectors and you can use only one vector, which is FR vector. That is the sum of these two vectors. The effect of these two vectors put together is equal to F1 vector plus F2 vector. But the modulus of, that means modulus means within two parallel lines, if you write a vector, it will come out as simply FR, as I mentioned here, it is FR will be equal to what? F1, this is 12 and this is 5. This is just 12 plus 5 that is equal to 17 Newton. So when two vectors act in the same direction, that means when two vectors are parallel to each other, because as such you see here F1 vector and F2 vector act along the same direction, then these two are a set of parallel vectors. When two vectors are parallel, the effect of the two vectors is the algebraic sum of the two vectors, and the direction is direction of any one of the vector. So if you want to write resultant vector is 17 Newton east. Magnitude of the resultant vector, that means magnitude of the resultant vector, which is Fr, is simply equal to 17 Newton. But it won't be added all the way. So why do we have to go to this much of pain to add all these things? Because force is a vector and they have to be added vectorially. Vectorially means without sacrificing the directional entity or the directional property, you have to add the vectors. When you try to do that, the sum of two vectors is not always the algebraic sum as I represented here. Let us take let's take another example. Like suppose there is a block, and this time you and your friend are not thinking alike. Suppose you want to pull this block towards east by applying 12 Newton. But your friend who is not supporting you is trying to pull the block towards west. Now, F1 vector is 12 Newton east. 12 Newton east. But F2 vector is 5 Newton west. Now, what is the effect of these two vectors? The effect of these two vectors is the sum total, the vector sum of two vectors. Vector sum. Let's say if there are n vectors, even if there are n vectors, we will be just adding all the vectors. Take the sum total of all the vectors, sum of all the vectors from first vector to the last vector. So the resultant vector, because there are two vectors here, the total effect of these two vectors is F1 vector plus F2 vector. But when you try to add these F1 vector and F2 vector, you know that it is 12 Newton east plus 5 Newton west. But west is nothing but negative of east. So it is 12 Newton east minus, that means plus of minus 5 Newton east. Because west is negative of east. Now it is totally 12 minus 5, which is 7 Newton east. That is how it is. And here the vector sum of two vectors gives you a magnitude, which is the difference between the two vectors, because these two vectors are act in the opposite directions. Then let us formalize this. When you add two vectors, what you did here, you moved the vector. When you move the vector, you should not change the direction or magnitude, because when you change either the direction or the magnitude, the vector will change. And here, because you just want to add the two vectors, what you need to do is you should not change the vector. If you want not to change the vector, you should not change the direction or you should not change the magnitude. So the length of the line should not be changed and the direction of the line also should not be changed. Now it is F1 vector and this is F2 vector. Now the sum of two vectors start here and goes here and then come back here. Then the resultant of these two vectors is from the tail of this first vector to the head of the second vector, as in the previous case. Because this line is 12 centimeter, this line is 5 centimeter, 12 minus 5 centimeter, this is going to be 7 centimeter. Because 12 centimeter represents 12 Newton, 5 centimeter represents 5 Newton, then the resultant 7 centimeter should represent 7 Newton force. That is how the resultant vector Fr here is equal to 7 Newton, but the direction is still towards east. So 7 Newton east. So the same thing, sum of two vectors here, Fr is F1 plus F2 vector yields you the algebraic sum here, but the same sum f1 vector plus f2 vector here is actually equal to the difference between the algebraic difference. Okay, so this is how the vector thing works. Because if you want to add two vectors, you should not change the vector. So you have to add the effect of one vector with the effect of the other. If you want to add it, don't change it. Then what if the case will be slightly different? Suppose here the same block, this is north, this is east, this is the plane on which it is kept, and you are applying a force of 12 Newton towards the east, and your friend is applying a force of 5 Newton towards north, and the block, it is going to go in between this way. And now if you want to add the vector f1 and f2, again what you are supposed to do is just take the second vector and without changing the length or the direction, place, you are just going to add it. How do you add it? When the first vector ends, begin the second vector. By placing the tail of the second vector onto the first vector, now the sum total of these two vectors is from the tail of this vector to head of the second vector. So this is the resultant vector R. In this case, you see resultant vector is f1 vector plus f2 vector. Here also f resultant vector is, you are just adding it, you are not changing the direction or magnitude. So it is f1 vector plus f2 vector. Because these two form the two sides of a right angle triangle, you know that the magnitude of fr is root over magnitude of f1 square plus magnitude of f2 square. So this is the magnitude of fr. Magnitude of fr is fr. This is equal to root over f1 square plus f2 square. And the resultant is root over 12 square plus 5 square. 12 square is 144 plus 5 square is 25, root over 169, which is 13 Newton. Now the resultant of two vectors, now if f1 vector is acting along the eastern direction and f2 vector is acting along the northern direction, then the resultant vector will be 13 Newton. This is east and this is north, so this is 13 Newton northeast. And that's how the vector. So this is not only for parallel vectors here like this, or anti-parallel vectors, and or the orthogonal vectors. The class of vectors that we have seen here, both the vectors are parallel to each other, so they are called parallel vectors, and these two vectors are opposite to each other, and this is an anti-parallel set of anti-parallel vectors. These two vectors are acting right angle to each other, so they are called orthogonal vectors. So when the vectors are parallel, the sum of that is the total magnitude of the vector is algebraic sum, and when the vectors are anti-parallel, the vector sum of two vectors is the difference in magnitudes, and when the vectors are orthogonal, and we will use Pythagoras theorem to find the resultant of the vector. In general, these are all specific cases. If you want to establish a general case, suppose if there is a block and let's say it's a small point and two vectors are acting on that small point, let's say any two vectors, like one vector is acting in this direction and another vector is acting in some other direction. If this is called the f1 vector, this is f2 vector, and the angle between them is theta, then the way of finding the resultant is the same thing. So take one vector, keep it here, and take the second vector without changing the direction and place the tail of this vector on the head. Now you have added two vectors. This is f1 vector, this is f2 vector, this is f1 vector plus f2 vector. This f1 vector plus f2 vector is from the tail of the first vector to the head of the second vector. This is called triangular law of vectors. If this is f1 vector, this is f2 vector, and this length is F1 vector plus F2 vector. This single force that is replacing these two forces is called resultant force. The resultant force of a set of vectors. The resultant force of a set of vectors is the sum. What sum? The vector sum of all the vectors acting 1 to n. When there are two vectors, we usually find the sum of two vectors by placing the tail of one vector onto the head of the other. By drawing a line from tail of the first vector to the head of the other vector, you will get the resultant vector. The length of the line represents the resultant magnitude and the arrow represents the direction. And you can find this arrow angle and this. So that is what we will be discussing in the parallelogram law of vectors. So you know the triangular law of vectors. When two vectors are acting at a point and place the tail onto the head of the other vector and draw a resultant vector, and the length of the line gives you the resultant vector's magnitude.